Okay, everybody, we're going to do a quick review of complex numbers. So the complex number system is anything that's either real or imaginary when we put them all together. So you guys are used to seeing real numbers, things like this, 7, 1/2, negative 4.3. Those would all be examples of real numbers, things that we can deal with in the real number system. So like integers, rationals, all those, irrationals. Imaginary numbers are things that have a component of I in them. So like 3i or negative 0.5i or square root of negative 4. All those would be examples of imaginary numbers, things that aren't real. And then kind of in this overlapping area in the middle, we have numbers that have maybe both parts. So they have a real part and an imaginary part. So when we put all of those together, just real or just imaginary, or a little bit of both pieces, we get what we call the complex number system, which is anything that can be written in this form, a plus bi, where the a stands for the real part of the number, and B stands for the imaginary part of the number. Okay, so we have those two pieces. So what we're going to do today, just really quick, this quick review, is look at all the different things you can do with the complex number system. Adding them, subtracting, multiply, divide, all those basic definitions. So before we launch into that, just make sure you understand how to do different powers of I, which you can also do in your calculator as well. There is an I button, so see if you can find it, because that'll be a nice shortcut for you. Okay, so I is defined to be square root of negative 1. So if we want to do higher powers of that, we just take that and do the definition. So the square root of negative 1 times the square root of negative 1 would be negative 1. So I squared is equivalent to negative 1. That's going to be super handy. I cubed, I'm going to write this as I squared times I. Then I can use the 2 that I've already done. I squared is negative 1 times I would be the opposite of I. So when I look at the equivalent, I to the third is equal to the same thing as opposite of I. Then I to the fourth, I'm going to use I squared times I squared. That's the easiest one. I squared is negative 1. So it's the same as negative 1 times negative 1. So I to the fourth is equal to 1. So if you look at these four values, I, negative 1, negative I, 1, those are the four values that this is going to cycle through over and over. Because if you do I to the fifth now, you could write it as I to the fourth times I. Well, I to the fourth is just 1 times I. We're back to the original. We're back to I. I to the sixth, I could do I to the fourth times I squared. Anything that's a multiple of 4 is 1, so it's 1 times I squared. Already know what I squared is. That's negative 1. And we can keep going. I to the seventh would be I to the fourth, I to the third. So 1 times I to the third, so negative I. And then I to the eighth would be I to the fourth times itself, or 1 times 1 or 1. So we keep cycling through. So if you can figure out where you are in the cycle and the pattern, it's pretty easy to figure out which one of those four values you're going to be. So if we try to do, say, I to the 39th, take the biggest multiple of 4 that's in 39, less than 39, which would be 36. And what you have left is going to be what our value is. So I to the 36, that's really like saying I to the fourth times itself 9 times. Well, any multiple of I to the fourth is always going to be 1. So we have 1 times I to the third. Our I to the third is negative I. So we just have to figure out where we are in the pattern, and then we can solve where that is. So multiples of I are super helpful to know. Okay, so what can you do with complex numbers? Well, you can do all the basic operations, add, subtract, multiply, divide. When you add them, if you didn't even know what I meant, you could still do it because you're just looking for like terms. You would add their real parts, and you would add their imaginary parts. So you would get 11 minus 2i. If you find your I key on your calculator, you will see that you can do that operation on your calculator as well, although that would take a lot longer than just doing the arithmetic. Be careful in the subtraction. Remember, when you do subtraction, you've got to make sure that that negative sign goes to both the real and the imaginary part. So plus 3 plus I, then we put our like terms together. So 4 plus 6i. So when you add or subtract, you oftentimes will end up still with a real and an imaginary part. Okay, when you have two parentheses next to each other, what operation is it? And you're screaming multiplication. All right, so multiplication, you do FOIL. So we'll do first, outside, inside, last. So that would be 2 plus 4i plus 6i plus 12i squared. Now normally when you do FOIL, after you FOIL, you put your like terms together. So let's do that. And take a look at this last term, 12i squared. If you remember, I squared is the same as negative 1. So what that really means is you have 12 times negative 1, or a minus 12. Maybe you remember that from last year. So when we put our like terms together, it'll just be something that can go together with the 2. So that would be negative 10 plus 10i. So just remember that I squared, negative 1. That really helps. Okay, let's FOIL one more just to be sure you're okay. So first outside, inside, last, that would be 6 minus 10i plus 12i minus 20i squared. And again, remember what happens there with that negative 20i squared. Negative 20 times negative 1, we're going to end up with a plus 20 there. So it changes the sign of that term. So I combine that with the 6. So 26 plus 2i. So I have a real part and an imaginary part. Okay, our last piece is that we're going to do division. When you're dividing, you got to be careful. If you're dividing by a binomial like this, that means you have a radical in the bottom, right? Because an I is a radical. It's square root of negative 1. So this is where you multiply by the conjugate. We did that at the beginning of the year. Oops, that's a U, sorry. We did that at the beginning of the year on that prereq skill sheet when we were trying to simplify things. You can't leave radicals in the bottom. The way to deal with that is you multiply the top and bottom by the exact same expression as the denominator, except the sign is opposite. So we're going to multiply top and bottom by 5 minus 2i. And what that'll give us is just an integer value in the bottom. We'll get rid of those i's. So let's do the bottom, do FOIL. First would be 25. The outsides and the insides would cancel. Negative 10i, positive 10i. I'm not even going to write them down. And then minus 4i squared. I'm going to keep going with the bottom. Remember the I squared deal. I squared is the same as negative 1. So a negative 4 times a negative 1 would be plus 4. So my denominator would be a 29. So what I've done is rationalize the denominator. On the top, you're just doing the arithmetic. First, outside, inside, last. So it would be 20 minus 8i plus 10i, and then minus 4i squared. So again, same deal. I got to take a look at that minus 4i squared. That's going to be the same as plus 4. Negative 4 times a negative 1. So I have 20 minus 8i plus 10i plus 4, and then I can put my like terms together. So put the 20 and the 4 together, so 24, and then plus 2i. Now when you're talking about the real part and the imaginary part, it's probably easier then to just do that division. So 24 29ths would be the real part, plus 2 29ths I would be the imaginary part. So again, you can do this on your calculator. Sometimes it's a little bit easier for something like this, but they'll give it to you as a decimal answer, so it looks a little gross when you're trying to simplify. So multiply by the conjugate. That's what we're doing for division when it's a binomial. If you take a look at number 4, you have something very similar, but they just wrote the divide a little bit differently. So they wrote it as with a division symbol. It still means a fraction though. So I'm going to multiply top and bottom by the conjugate, which would be 1 plus I. So we're going to do that in the top and the bottom. So in the denominator, first would be 1, last would be minus I squared. Remember, the insides and the outsides would cancel. So that means in the bottom, minus I squared would be like subtracting a negative 1, which is the same thing as adding 1. So the bottom would be 2. Okay, in the top, we're just going to do FOIL. So first, outside, inside, last. So negative 5 minus 5i plus 9i plus 9i squared. Okay, so let's remember what's going on with that. The plus 9i squared, that's like 9 times negative 1, so that's a negative 9. Put that together with the minus 5, we'd have negative 14, and then plus 4i. In this one, when we simplify to get the real and imaginary, you actually end up with integer values for each of those. So we would divide out by 2, so negative 7 plus 2i, divide everything. So multiply by the conjugate when it's a binomial. Okay, our last division one. This one doesn't have a binomial in the bottom. It just has an I. We still don't want it there, right? We still want to have something with whole numbers, but this is like having a radical in the bottom. Like if you had something like 2 over square root of 5. If you wanted to rationalize, you'd multiply top and bottom by square root of 5, right, to get rid of that radical. Well, this is the same thing. We're going to multiply top and bottom by the radical part, which is the I. So we're going to multiply top and bottom by I. We don't need to multiply by the 3. That's just a whole number. It's fine. So on the bottom, you'd have 3i squared. And on the top, when you distribute, that would be 2i minus 6i squared. Everything else is just simplifying. All right, so let's take a look at the bottom. I squared is -1, so 3 times -1 would be -3. On the top, minus 6i squared, that would be a plus 6. So I'm going to write the real part first. For me, that's easier. And then plus 2i. Simplify each piece there. So 6 divided by -3 would be -2. And then minus 2/3 I would be your imaginary part. So if it's not a binomial, you don't need a binomial to rationalize. We just need the radical, which would be the I. Okay, so there's a quick review of working with complex numbers, doing basic operations. Make sure you're okay with those. Give the worksheet a try, and we'll see how you do. See you tomorrow. Bye.